Hello subscribers and guests, and welcome to the channel. This is the first video in hopefully quite a long series where I will explain in an easy way difficult math topics, or just those topics where my students tend to have most problems. Today's video is about trigonometry. In this video I'm going to teach and explain you how to solve basic trigonometric questions and equations, paying attention and particular attention to the areas where most of the students who are studying with me tend to have mistakes. Let's start with a simple trigonometric question. For example, you have sine x, and that sine x is equal to something. Let's say 1/2. And you need to solve this basic equation. How would you do it? Well, before you solve any trigonometric equation, you need to pay attention to the domain and range of the function. Domain of the function is all x's that can be put into the function to get some sort of result for y. So to get any result for y. So for example, for sine x, so domain of sine x is anything. So in this case, x belongs to R, to any real number, meaning that any real number can be put into the equation and the function sine will return you some sort of the answer. But what about the range? So the range is a bit more difficult here, because sine x by definition cannot be bigger than 1 or smaller than -1, which means that if you have the sine, your y only belongs to the interval from -1 to 1, both ends included. So for example, if you have an equation that sine x equals √7/2, this equation does not make sense, so x belongs to nothing, because obviously √7 is bigger than 2, and hence √7/2 is bigger than 1. So before solving simple or basic trigonometric equations, you need to check whether it makes sense to try and solve it. For now, let's assume that you do have the good value on the right here, so that the equation is solvable, so it's inside the range of the sine. How to do it? First of all, you need to put on your calculator shift sign button, usually in most of the calculator models, and you get the answer for arc sine or inverse sine from your value, for example sine -1 of 1/2, and the calculator returns you the value either 30 degrees or pi/6 radians. And this is your first root. This is where many students stop, happy that they have found something, and do not think about the second series of roots and about the period of sine. So please pay attention that sine -1 from 1/2 is 30 degrees or pi/6, but this is not the only root. The reason for that is that sine function is periodic. It goes like that, and hence if you solve trigonometric equation, you are most likely to have two roots on the same period, as long as your y is not 1 or -1, or as long as it's not above 1 or below 1. So each 360 degrees, which is the period of the sine, you will have two roots, and the next period will have two roots as well. Therefore you need to find the second series of roots, and the second series for sine will be 180 minus whatever your calculator gave you. So minus sine -1 from 1/2, which is in this case 30 degrees, and you can write it as 150 degrees. However, this is not the end of the story. Let's rewrite those two series again. So sine x equals 1/2, then x will be either 30 degrees, x is 30 degrees, or the second series, x is 150 degrees. But then we need to add and subtract 360 degrees times n, which means that this root will be able to appear again and again on the next periods of the function of sine. So in order to explain it better, let's imagine, for example, you have March. Next March will be in 2 months, but after it there will be another March, which will be in 1 year and 2 months, then in 2 years and 2 months, then in 3 years and 2 months, and the March before was 10 months ago, so 1 year and 10 months, 2 years and 10 months, and so on. So the same applies for sine. Regarding cosine now, cosine is the function which is very similar to sine. So cosine x equals 1/2. It also has the range limited to -1 and 1, so your y, or the result of the function, can be anything from -1 to 1, but not beyond this. And it also has the period of 360 degrees. If you have the basic trigonometric equation, you need to take shift cos on the calculator, finding cos -1 from 1/2, and you will get 60 degrees, or pi over 3 radians. And again, this will be only the first in the series. There will be the second series, which will be 360, and this is important because 360 here is different from 180 for the case of sine. The rest is the same. So 360 minus that cosine -1 from 1/2, so that answer that calculator gave you, and then both series, of course, plus or minus 360n, plus or minus 360n, because the period of the cosine is the same as the period of sine. Moving on to tan. Tan is a more interesting function, because the range of tan is from -infinity to +infinity. So tan x equals 5, for example, makes sense, because range equals from -infinity to +infinity. So tan can give you any result. Therefore, you can straight, without checking anything, plug it into the calculator. Tan -1, which is usually shift tan, from 5 will give you by calculator a result which is about 78.7 degrees. So roughly 78.7 degrees. However, tan function has the period of 180 degrees. So it means that you should write here plus or minus 180n, not 360, as in the case of cosine and sine. The good news is that there will be no second series. So here will be nothing, and on the one period there will be only one root for tan. So let's recap the main difference between sine, cosine and tan. For sine, you should write sine minus 1 of your result, so for example 1 and 1/2 or whatever is given in the equation, in this case sine x equals 1/2. This is the first series. There will be second series, 180 minus that result, so minus whatever the calculator gave you, plus minus 360n plus minus 360n. In case of cosine x equals 1/2. Everything will be the same, but with only one difference. This 180 will be 360. So cos minus 1 from 1/2 plus minus 360n, or 360 minus cos minus 1 from 1/2 plus or minus 360n. For tan, there will be one series, tan x equals 5, tan minus 1 from 5, but plus or minus 180 degrees. So the key difference is here and their relative sine and cosine, and here, and there in the period relative to tan. I hope this will make it easy, and please do not forget the second series for sine and cosine. This is one of the most spread mistakes among students who study with me. Now let's move on to the second topic with a lot of mistakes, which is sine and cosine and tan, so any trigonometric equation with a complex argument of the function. For example, sine 3x plus 20 degrees equals 1/2. What to do here? So the simple answer is, do not panic, just replace the angle, so 3x plus 20, by y. So this is y. Then the whole equation becomes easier. Sine y equals 1/2. However, there are some underwater stones here. When you have written this equation, you need to keep y first of all as is. So y equals sine minus 1 from 1/2 plus or minus 360n as described before. And straight away please write the second series. Do not forget it. Y equals 180 minus sine 1/2 minus 1 of course plus minus 360n. Let's now rewrite it in normal angles. So y will be 30 degrees plus or minus 360, or y will be 150 degrees plus minus 360n. But after that, this is where the problems start. Students replace y with 3x plus 20, and they happily divide by 3. So 3x plus 20 equals 30 plus minus 360n, and 3x plus 20 equals 150 plus minus 360n. And this is where students, after shifting and subtracting both sides 20, tend to divide everything by 3. However, they do not divide 360, which is wrong. Let's see how to write it correctly. 3x equals 30 minus 20 plus minus 360n. 3x equals 150 minus 20 plus minus 360n. So this is obviously 10, so I will replace it straight here to save time by 10, and here by 130. So then you need to divide everything by 3, but not only 10 is divisible by 3, but you must divide the period by 3 as well. So the result will be x equals 10 over 3 plus or minus already 120 n, and the same with the second root, x equals 130 over 3 plus or minus 120n. Please do not forget to divide this period, because the function, when the argument is multiplied by a number which is bigger than 1, tends to be squeezed, and it repeats its roots more often. For example, if this is normal sine function, so this is normal sine, the compressed sine or sine of 2x or 3x will go up and down much more often, like the frequency will increase. And hence, if usually you get two roots, in this particular case when when coefficient in front of x equals 3, you may get up to 6 roots on each period, each 360 degrees. I hope this is clear and you will make less mistakes like that. That's it for today. If you still have any questions, please leave them in the comments below under the video, and I will try to deal with them as soon as possible. And please subscribe for the channel not to miss any new videos which may be useful for your Maths A-Level, IB and other maths programs. Thank you for attention and see you soon.